Hello students, welcome to my channel. Today we are going to learn about resolution of a vector. In addition, we also discuss about dot product and cross product. Let's start. Resolution of a vector. What do you mean by resolution? We generally know resolution means resolve or splitting something into many parts. Okay, resolution of a vector means here the resolution of a vector means splitting of a vector into different parts is known as resolution of a vector, splitting of a vectors. And also splitting process is called resolution and splitting is known as components. These two splitted vectors are known as components. The two components of a given vector perpendicular to each other. If this is a one vector and this is another vector, if they two vectors are this type perpendicular to each other, then two vectors, this vector and this vector, are called the rectangular component of another vector, which lie just this type. Okay, here is an example. Here is a figure. Look at the figure. We discussed from this figure. Here is a two rectangular components of a f vector, that is a force vector along x and y axis. Look at here. Here, look. This fx is a x component and this fy is a y component of this f vector. Consider a vector be represented by OP. This OP, this f vector is represented by OP vector. The vector also resolve into two rectangular components, fx and fy. We have already discussed about this. Here the triangle, in triangle OSP, OS and P, this triangle cos theta is equal to fx upon f. Cos theta means b by h, which means cos theta equal to fx upon f. This means fx equal to f cos theta. This is a x component. Similarly, for y component, if this is theta, then these two vectors are perpendicular to each other, then this remaining angle is 90 minus theta. In this way, this t in triangle OTP or OPT, this fy is a, here this fy is a vertical component, this 90 minus theta angle, then fy cos 90 minus theta equal to fy upon f. It means fy equal to f cos 90 minus this angle theta. That's why thus fx means f cos theta and fy means f sin theta. This 90 minus theta, cos 90 minus theta means sin theta. Okay, that's why in this way we can calculate this rectangular components of vector f. Similarly, you can do for velocity also. Applications of a resolution of vector. What are the applications? The man walking on the road. This is the application of resolution of vector. And similarly, it is easier to pull than push. We can pulling is easier than pushing something. Okay, this is like this type. If we push this, more force will be applied. If we pull this, less force will be applied. That's why it is easier to pull something rather than push. Here the dot product. Now in the second topic, dot product. Dot product is also known as scalar product. Here is a figure A dot B, that is A dot B. A dot B is equal to AB cos theta. Okay, AB cos theta. Geometrical interpretation of this vector is, here is figure A vector along OP and B vector along OQ. Then A dot B is equal to AB cos theta. Then B as it is, this AQ is a B dot product is B times A cos theta. Okay, A cos theta. This is a hypotenuse, this is base, A cos theta. Then B times A cos theta means this AQ. That's why this AQ is a normal to OP. That's why this is a component of A on B. That's why we can say that in geometrical interpretation, the dot product gives the vector of B times the component of another vector on that vector. Okay. Cross product or vector product. Here is cross product. A cross B. This into means cross here. A cross B is equal to A dot B. This A and B are the magnitude of vector A and vector B respectively. Okay. A dot B. That's why A dot B sin theta here. In dot product we use cos theta, and in cross product we use sin theta. And here is a n bar, means this is the direction of A cross B vector. The cross product of any two vector is also a vector. The dot product of any two vector is a scalar. That's why that is called scalar, and this is a vector. Remind it. Okay. Geometrically you can say that the cross product of two vector is a area of a parallelogram, and these two A vector and B vector are the two sides of that parallelogram. This is a cross product. Okay. The magnitude of a vector product of two scalar vector and gives the area of a parallelogram whose two sides represented by the two vectors. Okay. The direction of A and B. What is the direction of this A cross B? Here, the direction of A cross B is just like a perpendicular to the plane that A and B vector lie. Okay. Here, if we have a two vectors, this is A vector and this is a B vector. They lie on a plane, one plane. Okay. Then this A cross B vector lie on this direction, and this is perpendicular to that plane in which the vector A and B lie. Okay. We can demonstrate by this. If this is a plane, okay, this is a plane, this is one plane, and this A vector and B vector lie on this plane. Then this A cross B vector lie perpendicular to this plane, this direction, in this direction. Okay, this is A cross B. Okay, what I had said here, this is a plane where this A and B vector lie. Okay, this A cross B here, this type. Okay, and that product A cross B lie on this direction. The A cross B means this. The A cross B, if A cross B is a third vector C, then this C vector lies on this plane, right, like that. Okay, perpendicular to that plane. This is a cross product. Okay, this is a geometrical interpretation of that cross product. Thank you for staying with us. Thank you very much. Bye bye.